Hi everyone, I'm Makar. Currently, I'm studying at the Department of Mathematics and Mechanics of Moscow State University. About 2.5 years ago, I started working for a Teach-based company. They hired me even though I knew almost nothing in Ruby and knew little in Rails. They hired me anyway, and they didn't want me to break anything, so I got engaged in testing. Most of the time, those were acceptance tests. And I have a question to you. Who of you have been engaged in writing acceptance tests? So it is. And what are your impressions? It hurts. That's right. It is painful but useful. And since I'm a mathematician, I'd like to start with theory, particularly with the definition of integration testing. One moment. Is the sound all right? Yes. Perfect, thanks. As Wikipedia suggests, integration testing is the phase in software testing where individual software modules are combined and tested as a group. No comments on that. Acceptance testing can be defined as a type of integration testing where a finished product is tested. And it's not necessarily a website or a web application, and I'm going to get back to it later. The question is why? The answer is sort of like that. This is how unit testing looks like. All elements seem to be fine, but it's not quite clear how they will work together. As shown in the GIF, unit tests do not test modules collectively. And basically they shouldn't. Maybe it's not true for you, but then maybe it's better to rewrite them so that they would test things separately, because that's their main purpose. Secondly, if you are testing some unusual front-end, or you just don't test it at all, as we do at TeachBase, it's probably the only way to test the front-end, to see that it actually works, that nothing or almost nothing crashes. What do we need for that? First of all, we need Capybara, a Ruby gem which provides DSL for operations with a page, and matchers for our spec. We also need a headless browser. It's a browser without a graphical interface, and Capybara works with it through a certain engine. Normally it's Selenium, but sometimes it can be Phantom.js. And I'd like to dig deeper into the browsers. There are two options, as you can see here, Phantom.js and Headless Chrome. What differences do they have? Phantom.js is very easy to install. You just download it and run it. That's it. And it's gonna work. However, it has a deprecated JS engine, and here you can see what may happen. Yeah, it's the next point. It is deprecated as shown in this Rails pull request, and Rails recommend to use Chrome. But Chrome has another issue. It requires a Chrome driver, and that's another layer. We already have Capybara, then it's Selenium. It works with Chrome driver. Chrome driver works with Chrome, and when you install the Chrome driver and try to run it, it may lack some dependencies and you'll have to additionally install them. So I've spent more time installing it as compared to Phantom.js. Secondly, Headless Chrome can't provide a screenshot of a selected area. At least I couldn't manage to do it. This is quite important because taking a screenshot of a selected area, we can see what was going on in the browser, why a test failed or why a test passed, under which conditions it passed if it wasn't supposed to. And I'm going to tell more about screenshots in the second part of my presentation. And the third problem is that after the tests are completed, the Chrome driver must shut down. For that, it should send a request to localhost port 9515. And if you are using a webmock, it will cause an error. That's why you have to disable webmock after testing is over. Nevertheless, Headless Chrome is being updated. It has a fresh JS, and we are working with Chrome as one of the most popular browsers. Let's say we've chosen a browser with you, and we are moving on to the first testing options, which is DOM elements testing. The first thing we need here is interaction with a page. It is provided by Capybara with the help of two simple methods: visit and click on methods. Visit method allows us to get about URLs. The click on method allows us to click on buttons or links with the assigned text on a page. Apart from that, there is a matcher have something. Basically, you need to use only have content matcher because we are looking at user behavior. Here is an example of a simple test. It visits our app, clicks on profile link, and expects to see there clearly something else. Expects to see there a username, and I've applied mine. What's next? It's not the final option for page usage. There can also be filling out forms. For this, Capybara provides a fill-in method, which fills in a form by name attribute. And no other, as it seems. Also, choose, check, uncheck, and select methods, which work with radio, checkboxes, and selectors accordingly. A more complex test, we update the profile and we expect the page content to change. What can we get from it? An acceptance test describes user behavior, and secondly, if you take a look here, if you give it to an ordinary user, by the way I've tested on such, they can read it and understand it. They get what's going on here. Originally, it was intended that a QA engineer would be writing such tests, not us. But there is no such success story yet. A conclusion out of the 2 points I've mentioned is that acceptance testing is testing a black box. We shouldn't rely on internal implementation. Well, I've shown you some good test examples. A bad example is here. Why is it a bad one? Because we are relying here on some user model, that it contains a count method, count returns a number. This isn't quite clear to a user. In this case, it's worth using a have content matcher, visit the user list page if we really had created any users, and verify that it's there. Now, a question. We can't always perform actions one by one. Capybara consistently performs them one by one. But what if there is something from this list, asynchronous form submission, or content doesn't upload immediately, or there are some peculiar animations? There is always an obvious answer, but it's not fully correct, because the sleep method blocks the performance of tests for a certain time. It doesn't consider whether the content has changed or not, whether what's even going on there. Maybe there is nothing going on. Maybe the error should appear, but we have sleep. We have two other options. Option one, use the have-content matcher if Capybara can't find content. Its configuration contains a number. It contains a number responsible for the time we'll have to wait for the contents to be found eventually. Capybara will return an error only if no content is found. The second option is to write your own helper, which will basically do the same thing, but it will be more clear to the user. Here is an example of such a helper. Every half a second we check if some JS evals to true. If within a time of 10 seconds by default it isn't true, an error is returned. Examples of helper usage. Well, something's wrong here. Well, the example shows that we do not depend on JS framework. The first example is Pieces framework, which was written by our former CTO a long time ago, and that's the way it checks the absence of AJAX requests. If there are AJAX requests, Capybara will wait. The second example is wasted, but it is supposed to be jQuery. Our second what-if is that we have the click-on method. We need to submit a link or button text to it, and we have 3 identical buttons here. What are we going to do? There are 2 more magical methods. It's the within method, which allows you to limit our search by a particular selector. With some ordinary class, there comes a div with such class, and it will search for what we wish to click on. The second way can be used if we can't find a form field. Pieces doesn't use the name attribute with form fields, and what if we can't find a form unambiguously? Then we use a unique selector, which we submit to the find method, and work with an element obtained. Here it's worth mentioning that by default, within has a priority. So the upper test shown above is not good, because we load this element to the memory, and if there is no content now, but it appears later, the first test will never pass because our element is unchangeable. In the second case, we'll monitor the page updates, and the test is likely to pass if written correctly or if the application works correctly. That's basically it for DOM testing, and we are moving on to the next stage, visual testing. What's it all about? We visit a page, perform some actions on it, take a screenshot, and compare it to some prepared pattern. Well, what do we need for that? Initially, we found our spec page Regression Gem, which adds such a simple matcher. It automatically takes screenshots, and if the test fails, it suggests saving the test result. And then it automatically selects a screenshot to compare, and compares. Why do we need it? Capybara has a have-CSS matcher, which isn't very logical to test because a typical user won't dig into the page code. This matcher can be useful in the 2 following examples of teach base accounts with different settings. It shows the same page just with different account settings. In this example, the have content matcher could be enough, but let's imagine that there is no sidebar. Then we could use RSpec page regression match reference screenshot. Why else? Any other visualization testing. Generally speaking, we don't test it at all. Even front-end tests check particular elements rather than visualization. Secondly, it's regression testing, which verifies that the changes we had made in some place haven't led to faults somewhere else. How does it happen? First of all, well, we got two screenshots. How can they be compared? Pixel by pixel verification. We count the share of different pixels. If this share exceeds a certain established threshold, we can say that the images are different, and we somehow render this difference. What's the problem? You can hardly see that one of these images is darkened. Can you? Good. There is a minor difference, and we would want the test to pass if there is a minor difference in the color. If there is just this minor darkening. But the test will fail. That's why we refer to mathematical analysis, just as I promised. So a little bit of theory here. Equivalence relation is basically a function of two parameters with Boolean values and the following properties. In Ruby, equality operator is an equivalence relation. But not only it. We're going to use it later. Next comes linear analysis. I haven't announced, but here it comes. We defined vector space. I have simplified this definition. It's much longer, up to 20 lines in Wikipedia, because it lists 8 properties of addition and multiplication. Let's consider that these properties are obvious. Well, you can add numbers in a different order or multiply numbers in a different order and so on. An example of a vector space are real numbers. We can add them to each other or multiply by a number. That's easy. The second example is our three-dimensional space, where we can set a coordinate system and we'll add coordinate by coordinate, multiply by a number, component by component. That's how it's going to work out. Our next definition is metric. Metric is a function of two elements with the set properties. A metric is generally a distance. The distance in the 3D space fully complies with these properties. In particular, the last inequality is the triangle inequality. And several examples. First, the distance in a 3D space where x first, x second, and x third are components of the first vector, and y first, y second, and y third are components of the second vector or a point. The second example is discrete metric. In discrete metric, a distance between 2 points equals 0 if it's the same point, and equals 1 if the points are different. The last formula is Manhattan metric, called so because Manhattan is made of blocks, and if we want to get from one intersection to another, that's how we can calculate the minimum distance to be covered. But there are two components because we view the district as a plane map. We can view an image as a set of vectors in a 3D space, where the coordinates are color channels, red, blue, and green. The first algorithm used in RSpec page regression uses discrete metric. Pixels are either equal or not, and calculates the average distance between the pixels. The share of different pixels is the average distance. And the equivalence relation, if all pixel components are equal, the pixels are equal. I remind you of the image. Here is the initial algorithm. It showed the average distance 0.43. The color of the brain in this image is not black, it's slightly red. It is obtained through the difference by channels between the two images in modulus. The background should be black, not white, because if the colors are the same, the difference between them is color black, 0, 0, 0. I made it white for your convenience, for this particular screenshot. Is there any other way? Well, we can apply the following metric for the pixels. It's the distance in the 3D space. It is divided into a possible maximum distance to obtain a distance from 0 to 1. And we're going to calculate the average distance in the same manner, and we'll consider pixels equal if they are equal channel-wise. In that case, the average distance will be 0.01. And it's more like what we would want to get. The images, in fact, were very much alike, and the distance appears to be quite short. The distance here is the black and white background of one of the images, and it is reddened a little. The transparency of this red complies with the distance. You can see that it's slightly reddish, and the red frame is the region of difference. The second way is the following. We'll consider pixels equal if they have the same brightness. And here we introduce a new equivalence relation. Brightness is a linear combination of pixels, that's why it's quite simple and is an equivalence relation. We'll allow a measure of inaccuracy here. If the brightness is just slightly different, we'll still consider the pixels identical. And that's an old picture here. For some reason, probably my reader has included it. There shouldn't be any picture here, as the distance is 0 with inaccuracy 8 brightness points. And the images will be considered fully identical. Yeah, and here the image seems to be correct. Yeah. You can see that the region of difference is smaller than in the two previous tests. The measure of inaccuracy has been reduced, and here the difference is rendered as a black and white background with little red dots hardly visible to you. There are very few of them. The average distance is calculated here in the same way. It's the share of unequal pixels. How can we apply all this to testing? First of all, we've written a gem which implements image comparison following the given algorithms. And secondly, we've forked RSpec page regression gem and included an eye matcher. That's how you can compare screenshots from an application or from something else in different ways and get acceptable results. It could not necessarily be an application because we had an idea of using it to test document rendering. If you are rendering a PDF report or an Excel report and you can save it as an image or take a screenshot of it, you may also check it. What problems are there? There might be launching problems such as CI, because if you are using fonts but not using a Docker, it will be hard to launch it in CI. Secondly, even when comparing following the first algorithm, the fastest one, it's still going to go very slowly. As there are many pixels, they can be of arbitrary size. You can resize the window, of course, but there still be quite a few pixels. We've been solving this problem by limiting a screenshot with a particular selector, but it can't be done in Chrome. In Phantom.js, such tests went fine. Maintenance problems. If we change the page view, all the tests which cover this page area will have to be rerun. The screenshots will have to be retaken. If we've changed the text on a page, it's the same story. As for the support of the first test type, it depends on the texts. In most cases, it's better to use localization through I18N. What other issues are there? It is still quite slow. We have a solution, still in concept, how to recompile assets in a test environment. However, it's unclear how faster it's going to work, but at least something. Secondly, we can remove database cleaner. Why do we need it? Usually, in the test environment, all reading and recording is wrapped in transactions and then is rolled back afterwards. When we use Capybara, we have our spec and a server which independently work with the database. So turning into transactions won't work by default. We have to remove transactions and enable the database cleaner, which would clean the whole base after each example, and it's not very good. That's why we offer the following solution. We'll write everything through one connection. But there is another problem. If we just write it this way, the database won't understand. It'll be receiving separate request lines, maybe even separate figures. So the database won't be happy. So before submitting a request to a database, we lock a mutex, which will make the requests one by one from different threads. That's basically it. Questions welcome.